This is Algebra 2, Lesson 5. Today we're going to talk about word problems and fraction parts of a number. In word problems, in general, to obtain a unique solution for an equation, the number of equations must equal or exceed the number of unknowns. For instance, if I have 2x plus 5 equals 10, I have one unknown, I only need one equation. But if I threw in a y in there, I need to have a second equation to solve it, and if I threw in a third, I need to have three equations. So the number of variables that you have in your equation must equal the number of equations that you have in order to solve. If I had two equations, there's no way I could solve this with one equation. Okay, so basically that's what we're saying. And we're also saying that we're going to start with equations that have one equation and one unknown. If the equation tells us how much two quantities differ, then one of the quantities must be increased or decreased as required by that statement so the equality can be true. So let's look at example 5.1. It says twice a number is decreased by 7, and this is 9 less than the right side. We can make the sides equal by adding 9. The result is 9 less than 10 times the number. What is a number? What does that mean? Well, first it says twice a number, so we have 2 in twice the number, 2 times, is decreased by 7. Decrease means minus 7. Twice the number is decreased by 7. And the quantity is multiplied by 3. So the quantity, this, is multiplied by 3. The result, the answer of that, is 9 less than 10 times the number. So 10 times the number, 9 less than that. Does that make sense? What if I were to write it like this? No, that's wrong, because it said twice the number decreased by 7 and the quantity times 3 gives you the result. The result is 9 less, so this answer is 9 less than this, than 10 times n. So there's our equation. And now we simply just solve. And we have to use our distributive property with this 3. So we have to use our rules for solving an equation. 3 times, you have 2 terms in here, so you have to multiply 3 by both terms. You can't forget 1, you can't forget any signs. 3 times 2n is simply 6n. 3 times a negative 7 is a negative 21. So we got rid of parentheses. Next thing we do is we have to combine like terms. Do I have like terms over here? No. There's nothing to combine or simplify. What about this side? No, there's not. Now I need to remove my variable from one side or the other if I have it on both sides. I have a variable on the left, I have a variable on the right. Minus 6n, minus 6n. This simply becomes 0, negative 21. You can't forget about that negative sign there. 10, this is a positive 10 and a negative 6, which becomes positive 4n minus 9. Next step is to eliminate the constant on the side of the variable. Is there a variable over here? No. Is there a variable over here? Yes. Is there a constant? Yes. So we do the opposite. What we do to one side, we must do to the other side. This simply becomes negative 12. We divide both sides by the constant, and we get n equals negative 3. As simple as that. Let's do another one. The trick is going to be setting these up, listening to what it says, and think about it. If I say all this is happening and the result, or it's equal to this plus 5, or this 5 more, plus 5 more. So let's look at 5.2. It says the number of ducks on the pond was doubled when a new flock landed. Then 7 more ducks came. The resulting number of ducks was 13 less than 3 times the original number. How many ducks were to begin with? Well, we can use the number of ducks in the pond was doubled when the new flock landed. So we have 2 number of ducks. This stands for number of ducks. And we're going to learn subscripts, so it's not any different than just writing a simple N. But we're going to learn subscripts as we start doing more complicated problems. So just be aware of that. That's just a subscript. It's not any different just than a plain variable. Okay, so the number of ducks was doubled. Doubled always means 2 times when the new flock landed. Then 7 more ducks came. So we have 7 more. So we add 7 to that. The resulting number of ducks was 13 less than 3 times the original number. 3 times the original number, and this was 13 less than 3 times the original number. So we could take 3 times the original number and minus 13, or we could simply add it to this side because we said this was 13 less than 3 times the original number. So depends on what side of the equation you put it on will decide what the sign is. So we're going to put it over here because I like working with pluses better than minuses. Alright? So now we just simply solve. We can combine those two. Number of ducks plus 20 equals 3 ND minus 20 minus 20. I get 2 number of, or actually, I'm not going to do that. I could do that, but that's a longer step. I could simply just take this to the other side, and I get 20 equals ND. So my original number of ducks was 20. It's as simple as that. Now let's look at 5.3. It says, which is on page 40, it says the sum of -7 and 6 times the number is multiplied by 5. The result is 332 less than 3 times the number. What is that number? Okay, it sounds complicated, but it really isn't. But you have to really think. And what is it saying? It says the sum. What does sum mean? So it's 2 numbers added together. The sum of -7 and 6 times a number. So, right, the sum, so tell me the sum, here's the sum of -7 and 6 times a number is multiplied by 5, so you have to put this in parentheses because it says the sum is multiplied by 5. The result, I'll make sure you can see this over here, sorry. The result is 332 less than 3 times the number. So, 3 times the number. So this is 332 less than this. So I need to add 332 to this side. Or I can simply do it like this. One side or the other. Alrighty? So we're going to leave it on the plus again. I like working with pluses. And simply, now we just solve. And you can't forget your rules for solving. First, you do parentheses. These parentheses, you can't combine the inside of them because they're not like terms, but you've got what's called the distributive property, and we said that's included in parentheses. So you take this number times every term. 5 times -7 is -35 plus 30n plus 332 equals 3n. Now you combine any like terms. There's only one term over here. There's nothing on the right side to combine. What about over here? I can combine these two simply. So that becomes, let's see, because they're different signs, you find the difference. So you have 30n plus 297 equals 3n. So you're going to take this minus 30n to the other side, and you get 297 equals -28n, and you simply divide by -28 on both sides, and hopefully they've done that for us. Oops, I must have done some bad math somewhere. Oh, it's 27 here. Excuse me. So you get n equals negative 11. So that is what your original. So the hardest part is just going to be setting this up. All right, now let's talk about fractions. When we're talking about fractions of a number, we talk about a part of something. So when we multiply a number by a fraction, we say that we've taken a fractional part of the number. For instance, if I multiply 3/8 by 40, I said 3/8 of 40 is going to equal to 15. So 3/8 of the whole is going to give me the part, basically what they want you to say. So we say with these words that 3/8 of 40 is 15. We see that 40 associates with of and 15 with is. But I like to say of is represented by multiplication and is usually represented by equal sign. So, but they give you the number fraction times of equals is. So let's look at a problem. Look at 5.4. 1/5 of the clowns had red noses. If 30 clowns had red noses, how many clowns were there in all? So 1/5, so this stands for fraction. So what's our fraction? 1/5 of the clowns, this would be clowns, had red noses. So how many, it says if 30 clowns had red noses, how many clowns were there in all? So this, when you take a fraction, it's a fraction of a whole, is going to give you the part, the fractional part of it. So they told us there's 30 red noses, clowns with red noses. So that's going to go over here, 1/5 times C for the number of total clowns. And I simply solve for C. How do you do it? You multiply by its reciprocal. So there were a total of 150 clowns. Simple as that. Another way of looking at it, which I like to say, even though you use F times of equals is as your F is the fraction, of is the whole, and is a part, I like to say part over whole as your fraction, and this is of, so you have fraction times, or fraction of whole equals part. Are you with me? Fraction of whole equals part. Of is part, and of stands for times, is stands for equal. This is whole, this is part, and this is fraction. So they're the same thing, they're just using different wordings. Okay, so let's look at another problem. So we're going to look at example 5.5. This is 7/8 of the Tartar horde rode horses. If 140,000 were in the horde, how many did not ride horses? Well, we have our equation. They said there were 140,000 total. How many did not ride horses? They said 7/8 of the Tartar hordes rode horses. So we have 7/8 rode. The question is how many did not ride? So you have to find did not ride. Well, you know that together they have to equal one whole, or 100%, to equal 100%. So we have to take 1 minus 7/8. We simply do 1 minus 7/8. We use our fraction. We borrow. So that becomes 1/8. So 1/8, or you should be able to look at it and say 1/8, did not ride horses. So that's our fraction. Because our question asks how many did not ride horses. So 1/8 of what was the total? We had 140,000. And the way the words they use in this book, you have to be very careful because it's hard to tell what they're actually saying unless you're familiar with the terminology. So 7/8 of the Tartar horde rode horses. If 140,000 were in the horde, how many did not ride horses? So you want the part. You're looking for part. right? Fraction of the total equals the part. So you go and you divide 140,000 divided by 8. Excuse me. So equals, P equals, excuse my bad handwriting, 500, excuse me. 17,500. Did not write horses. Okay? They told you 7/8 row, but the question asked how many did not. So you had to subtract 1 from that to find out how many did not, and the fraction happened to be 1/8. So be careful with those types of problems. Okay? That is it.